Okay, this video is 6.6 video for 102 lecture and online, and I was just wanting to start this video with a recap of expressions and equations, because in 6.5 all we were dealing with was expressions. Expressions are simplified and reduced. They have no equal sign, and we have a couple of pre-algebra examples down at the bottom. 2 forces reduced down to 1 over 2, and x over 3 over x is reduced down to x squared. So basically you're just trimming the fat, getting rid of all the extra stuff, and getting it down to the basic reduced form. And that's what we did in 6.5. We would take oodles and oodles of terms and chop them down to get the basic term, the reduced term. And in 6.6 we're going to do the equations, but the only thing we're going to use from 6.5 is that common denominator. You used it in 6.5 to reduce, and in 6.6 you're going to use it to clear the fractions. And that's what we're doing, is clearing the fractions in 6.6. 6.6. And you can see we do equations in pre-algebra and algebra 1. You see you've done it before. So we're just taking 6.5 and 6.6, kind of meshing them together a little bit, the concept of the common denominator, and we're beefing up these things that you learned back in pre-algebra and algebra 1. We're beefing them up as far as the challenge goes, and putting more stuff on the problems so that you can work and take apart a problem when you see it. Not that anybody's ever going to walk up to you and ask you this stuff. They will ask you to solve problems, whether it be personnel, financial, mechanical, whatever the case may be. Any problem has to be broken up before you can solve it. Here's a problem I've already started. We started this at the end of class the other day. Wasn't able to video it due to some technical problems. And that's the problem we started. We may have jumped the gun a little bit and said that the common denominator was 3x squared. That's not the case, because you go with the highest the highest exponent, and the highest exponent is 1. I don't know why I thought it was 3x squared, but it's not. Then it was at the end of the class and I was kind of rushing. So let's just start off this video with the problem that we ended up with, that we were going to start in class. Like I said, we will be using the highest exponent, and the highest exponent is the x to the first, to the first power would be 1, so that's what our common denominator is. So I'm going to multiply by the common denominator over 1 and multiply through all the way, and that's what I did. And the 3 x's cancel, that leaves you with 2. The x cancels, that leaves you with 3 times 1, and 3x times 10 is 30x, and then that will give you 5 is equal to 30x, and get x by itself, divide by 30, and x is equal to 5 will go into 5 one time, 5 will go into 30 6 times. Your answer is 1/6. Now this concept 6.6 is basically this concept right here. Solving complex rational equations by clearing the what? Clearing the fraction. Now that's pretty basic. Clearing the fraction is actually simplifying a complex rational equation. That's what it's called. But you're basically clearing the fraction. And that's essential to make things a whole lot easier. Let's try another one. This problem is 2 over 3 minus 1 over x is equal to 7 over 3x. Again, we're going to multiply through by the common denominator. We got an exponent of 1 here and 1 here. So the highest exponent is 1. So we're going to multiply by 3x over 1. Put my baby step in here. And there's the baby step. Now we do our canceling, reducing, whatever you want to call it, that you learned back in 6.5. The 3's cancel. That leaves you with 2x minus the x's cancel. That leaves you with 3. And the 3x's cancel. And that leaves you with 7. Now, I don't know about you, but I believe this is a whole lot easier to work with than this. Add 3. 2x is equal to 10. X is equal to 5. And of course, we have to plug and chug to check. Now, this is also a time that you have to check something else. Remember what we're dealing with here. These are called fractions. And what can you not have in a fraction? You cannot have 0 in denominator. So you have to check. Each time you get a solution, you have to mentally, and I tell people to do it mentally because unless you're told to do it physically, you need to take that number and you need to mentally plug it in there, there, and there, in all 3 of these denominators. Now, of course, the 3 is a constant, so you don't have to worry about that one. Okay, 1/5. Yeah, you can have 1/5. And 7 over 15. Yes. Okay, everything checks. You can have all those numbers. If you plug that number back in and you get a 0, like if this was a x minus 5, and you plug in a 5 and get a 0, then the answer is no solution. So, I'm going to go ahead and tell you this right now. There will be problems that you have on homework and test. And if you don't do this, you're going to get the problem wrong because the answer is no solution. So be careful. Make sure you do this. Make sure you take that number, plug it back in mentally in the denominators to make sure that you're not going to get a 0. Now let's try another one. This one's a little bit more challenging. Common denominator, well, we need to factor a little bit, so I'm going to just factor up under it. X plus 2, x minus 2, that's that. Shortcut number 3. Factor out a common term, and x plus 2 is just sitting here. So what's the common denominator? Well, they're all prime of each other, so that means you just put them all together. So the common denominator is x times x plus 2, x minus 2. So you're going to multiply through by, and I'm going to write it right here, multiply through by x times x plus 2 times x minus 2 over 1. And I'm going to put that in here. I'm going to try to put it in here. I'm going to have to write small. So x times x plus 2 times x minus 2 over 1. X times x plus 2 times x minus 2 over 1. And x times x plus 2, x minus 2, oops, well, hopefully you can see that, over 1. And I'm going to multiply by 6 over x plus 2, x minus 2 equals x plus 1 over x times x minus 2 plus 1 over x plus 2. And I know that's kind of cramped, but that's all I guess I could have turned it around. Let's do that. Let's turn it around. Let me just rewrite it over here. Let me turn it this way. There we go. I think I'll start doing it that way. Alright, let me rewrite what I just did. Okay, 6 over x plus 2, x minus 2, and then x plus 1 over x times x minus 2. Let me go ahead and do the last one. And then 1 over x plus 2. Alright, so there's our, and that's equal to, and plus. And I'm just going to put the plus in the middle because I don't know where I'm going to put everything else. Alright, so now I'm going to get my red marker and put in my x times x plus 2 times x minus 2 over 1, and then x times x plus 2 times x minus 2 over 1, and then x times x plus 2 times x minus 2 over 1. And let's cancel out. The x plus 2, x minus 2 cancels out, and that leaves 6x. 6 times x is equal to, well, the x minus 2 cancels, and the x cancels, and that leaves x plus 2. Plus, the x plus 2's cancel, and that leaves you with x times x minus 2 times 1. And now you have basically an algebra problem, a little bit more basic, because you don't have a bunch of fractions or a bunch of rational expressions. So 6x is equal to x squared plus 3x plus 1 plus x squared minus 2x. Combine like terms. 6x is equal to 2x squared plus x plus 1. Bring the 6x over. 0 is equal to 2x squared be minus 4x, or 5x, sorry, minus 5x plus 1. And see if this is factorable. If not, then you don't have a solution. So let's just see if it's factorable. And that will be 1x and 2x and 1 and 1, and it is not factorable because you'll never get 5 with 2 and 3, so it's not factorable. So the answer would be no solution. Okay. So hopefully that helps. There will be times that you get problems that have no solution. Just like you'll get problems that have infinite solutions. Just recap that. Sometimes you get x is equal to a number. And if you've done the math correctly, if you get x is equal to a number, then that means that is the solution. And you plug back in to check it to make sure that you did the math correctly. And it should give you an equal equation. And what if you get x is equal to y, which cannot happen, or 4 is equal to 22, or x or 3x is equal to 4x. Okay, you get something. No, that wouldn't be right. 4y. There we go. You get something that doesn't equal. Then what you have is a contradiction. And a contradiction means you have no solution. So if you get something funny or you get something that's not factorable, basically your answer is no solution, or it's prime. Okay? And then you have the alternative to the contradiction, which is called the identity, and that is 4 is equal to 4, x is equal to x, 107 is equal to 107. And if you get these, that's called the identity, and basically infinite solutions. So just remember that, and you also need to remember, and this is a big remember in this class, and in this section, plug in solution mentally. To check if 0 is in denominator. Okay, that is a big thing, because I would hate for you to do all of the work, 99 or 100% of the work, and get it 100% right, but forget to check it and get a wrong answer and you've done everything correct. So hopefully that'll work for you to do 6.6. In the next video we will do 6.7.